Good morning, class. Today we're going to be talking about data binding, which is a very powerful technique that we use in Windows Presentation Foundation, as well as in some other areas, but we're going to introduce and work with it primarily in terms of Windows Presentation Foundation as a way of pulling data into our GUIs and then also pushing data from our GUIs back out into the data objects that we've been creating. So without further ado, let's jump into our code and we're going to explore this concept in a little more detail. So at this point, we already have started using data binding. You'll notice that in the project that we've been building, the shopping list control, we have a list view whose item source is binding. And you might be wondering, what exactly does this mean? And I promised you we'd come back to it. Today we're coming back to it. So when we declare something in these curly braces as part of a property in XAML, what we're actually saying is we're going to instantiate an object. So this is actually representing a binding object. And that binding object is going to serve as a connection between our control in our GUI, or in this case, the list view, and the data object that is stored in our data context. So this is saying, I want to use as my item source whatever the data context currently is. And if we think about our data context, well, we declared what that was in our main window. Remember that every WPF component has a data context property. It's part of one of the base classes. They all have a data context property, which type is object. And we can set that to any object we want. In this case, an observable collection of line items. Now, with the elements tree, there's another element to those data context, and that is basically if we don't set a data context, a component will use its parent's data context. And if that one doesn't have a data context, it will use its parent's data context all the way up the tree. So at this point, we have declared in our main window that the data context is going to be that collection of line items, which then our grid does not change what its data context is, so it gets that same data context, and its child, the shopping list control, then we jump down the tree to the shopping list control. It gets the same data context, because again, we're not changing it, and so this dock panel then gets that same parent's data context, and finally our list view gets the parent's data context. So when we have this item source binding, we are binding back to that collection that's the data context that has come all the way down the tree. So we are binding this list view directly to that collection of objects. And what that list view is going to do, it's going to iterate over those objects and it's going to render them in its list. And if we go ahead and run this, we saw this last time when we worked on this project last time, but we are going to show that it displays the eggs which we added in the main window, and we can add to this list. We could add, for example, grapes. And as soon as we click that add to list, so now in the list, we've changed the observable collection's contents, and that has automatically updated this GUI, and it does that through that binding class. So let's dig a little bit deeper into how that is actually working. And to start with, we'll look at what we're actually rendering. What we're rendering is the effect of calling toString on the object, because the list view doesn't know how to render an object. And we're going to go ahead and change a property of this list view. And when we do that, there's basically two ways we can set properties on a XAML object. One is this inline style where we declare an attribute and then set it equal to something. The other way is we can actually nest inside that object, so in this case the list view. So inside this control, we can say list view dot in the name of a specific property. And the one we want to work with here is the items template, or item template. And the reason we might do it this way versus the inline version is if we have to put something in that's kind of complex and going to have multiple nested elements, that is very hard to actually specify with this curly brace style syntax. So this is often a lot easier. And you've already seen this when you worked with the grid. We did the grid.column templates, or grid.columns and grid.rows. Those were individual properties, and then you're putting a collection inside of those. So you're saying, I want to instantiate with this many rows and this many columns, and they're going to be this wide, and all of those details. So we've already used the syntax, but this is really what it is. We're exposing a property and we're setting that property. So the item template is a template that gets applied to each item that's being rendered in this list view. And it needs to be a data template. And then inside this data template, we can put whatever WPF controls we want. And to get us started, let's use a text block. And the text block has a text property, which is the text it's going to display. And here I'm going to use a binding again. And then I'll self-close that text block. So what I've done here is I've said, okay, what I want you to render, instead of your default, I want you to render a data template where we're going to render just a single text block. And in that text block, we're going to have a binding to whatever our data context is. And if I run this, you might be wondering what that's going to do. Notice it still says eggs, and if I put something else, maybe syrup, it will add that to our list. So this looks exactly like it did before. So what did we change? Honestly, we didn't change anything because the default data template is exactly this right here. It's exactly that code. So this is what it does by default. It takes and binds the text property of a single text block to whatever is in that collection, so whatever we're iterating over. Now, that collection is a collection of these line items, which are objects. And because you can't just display an object, it will normally invoke the toString, which has been overridden to display the name, and we did that last time. So it is invoking the toString. Now we could bind it to something else, like we could actually bind that to this name. That's just not the default way that it does that. So let's go back to that shopping list control, and let's explore that. So with the binding object we're creating here, there is a path property, which determines what property we want to bind it to. So if we just have the binding, we're binding to the overall object. If we have a path, we're binding to a specific property on that object. So let's use that name. And you might be saying, wait a minute. We're bound to a collection. That's what our parent was, right? Our parent binding right here is the collection of line items. But when the list view renders itself, it actually iterates over that list, and then it will render this data template, and it will set the data template's data context to the individual item from the list. So we'll bind to the first item in the list, the second item in the list, the third item in the list, one at a time, and it will render each one of those. So inside this data template, what we're actually bound to is the line item that came out of that collection. So then we can actually bind directly to the name. So if we run this again, it should still display the same information because the toString was basically invoking and returning the value of the name. So not much different there, but you're starting to see how these individual pieces fit together. Okay, let's take it a step farther now. Rather than just displaying the name, let's go back and let's add the checkbox next to it. So we have a checkbox that we can mark off to say, I found this item in the store. As I'm walking through the store, maybe I'm using this on my phone, and I want to make sure that I grab everything I'm after. And if we look at our line item, we have this Boolean is found property, which we'd like to bind to that checkbox so that when we check that box, we're setting this property. All right, so let's go ahead and do that. If we go back to our shopping list control XAML here, we want to add a checkbox in front of this text block. And to indicate that it's checked, we have an isChecked property, which takes a Boolean value. As you can see, it can be false or true. Well, we can bind this to that isFound property, which is what our path is going to point towards. And if we do that, then it should display a check mark if that property is true, or it should be unchecked if it's false. Now, another thing you'll notice is as soon as we did this, it starts complaining. And basically what we've done is we have two children of the data template, and the data template can only have a single child. So this is not a layout element. This is a regular element, so it can only have a single child. So if we want to have two children inside of it, we need to nest them inside some form of layout. And one of the easy ones to do is the stack panel, which stacks elements one on top of another by default horizontally. Now we want these to be side by side in a line, so we're going to have to tweak the orientation of the stack panel. And you might be wondering, well, how do we do that? We need to look up the actual properties for that. If you look in the textbook or MSDN documentation, you'll see that it has an orientation property. And we can set that to horizontal or vertical. So we're going to set that to horizontal. And now if we run this program, we should see a checkbox next to eggs. We should be able to check that. Now, not terribly fancy yet. Let's look at the data binding side of things. So if we go back to our line item here, I'm going to add a breakpoint to this is found. So we just come over here to the side, and we're going to drop a breakpoint there. That means that if anytime we invoke the getter or the setter, we're going to hit that breakpoint. And I'm going to run this again in debug mode. And notice we immediately hit this is found. That happens because we have that binding set up. So as it's rendering that control for the first time, that control says, oh, I've got a binding to the data context. The data context has an is found property, which I am bound to, so I will invoke its getter. Notice that it's highlighted the getter to say the getter is what's being invoked. So it's looking at what is that current value. And that current value is false, so it is not checked here. Now if I check this box, notice we come back in and we hit it again. And we are actually hitting the setter this time. And the reason we do that is we have now set that value. So if I come back and hover over this is found, well, actually I need to be at a breakpoint. So we'll try that again. We'll just pull this back up. Let's add another item. And as soon as we add this, notice we hit the getter again because this new item we're checking to see did we actually pick up that item. And we can hover over this is found and it shows us it definitely is false. This is the is found for the syrup, not for the eggs. And if I check the syrup now and I come back and I hover over that is found, now it's set to true because that data binding actually goes back to the object that's created in memory and changes its value to reflect what we just put in the GUI. And this is the real power of data binding. This is a really awesome thing that it can do for us. All right. So now that we've done that work and we've seen how that data binding actually comes into play, let's dig a little deeper and let's add, in this case, a custom collection which is going to replace what we've been doing up to this point. So if we go back to our main window XAML, we've been using this observable collection as our collection of line items. And that works perfectly fine if we don't need anything specific that is unique to our particular collection in this case. Now, if we want to add something that is specific, like maybe we want to keep track of how many of the items have been found or how many still need to be found, then we need a little bit more. We need something that is not just the observable collection, but something that has some additional properties. So we're going to implement that now. We'll go ahead and add a new class. And we're going to call this class shopping list. And this is to replace that observable collection in our data context. So it needs to be public, and it needs to implement the iCollection interface so that we can treat it as a collection. Now, there's a couple different ways we could do that. We could go ahead and say it's going to be an iCollection interface and implement all those methods. We could do the whole collection ourselves, like you did in the data structures class. Or we could use one of the existing system libraries. And there's a couple different techniques we can use there. Probably the quickest is to actually just say, oh, I'm going to inherit from list or some other collection of line item. And at that point, this now has everything the list has. It inherits it all. Or we could make it an observable collection. And again, we would inherit it all, and we'd have all of those pieces, and we really don't have to write a ton of code. We'll come back to that idea. I actually want us to implement it explicitly because we learn a lot more from that. So I'm going to actually say that we're going to create an iCollection. And that iCollection is a collection of line items. And then once we do this, there's really two ways we can do this. We can actually, like I said, build out the whole data structure ourselves from the ground up, like you did in 300, or we can use a private backing collection. And in this case, I'll use a list because I think you're probably most familiar with the list. But we could really use any collection we wanted to. And we just create it. So this is a private backing field of type list, and it's very important that we actually construct that list. If we don't, then the value of items is actually null, and the first time we try to use it to do anything, that's going to fail. Now, in order to be an iCollection, there's a whole list of methods that we need to implement. For example, the very first one, we need to have a method for adding a line item. So we can define that, public void add. And then we want to add this to our collection. Well, we have this private collection, and we can just invoke our add method on that. This is what we call pass-through functionality, because our method's not doing anything unique or special. It's basically just passing through responsibility for adding a new item to that private backing field. The same thing for the remove. Now, remove is a little bit different in that it returns a Boolean. But basically the idea behind the remove is that it should remove the item and return true if it was successful in removing it. And if it was not successful, it should return a false. And the reason it would be not successful is it couldn't find the item. An easy trick for the pass-through here is we can return the value that's returned from item.remove. So again, we're just passing through. This is actually not that involved, just that we need to understand that the remove is going to return a true or false, and that we need to return that from here. And if we do that, that gets us where we need to be. Except this needs to be items. There we go. And we can do that for the rest of the methods. Now this is one of the few places where using the show potential fixes. I don't normally like you doing this because I want you to actually write these things out by hand. But a lot of these methods, especially things like clear, contains, copy to, you're probably never actually going to use these, but they need to be there. One of the ways you could do that, notice it says implement interface through _items. So this is the pass-through fix. We've already done the add and remove, which are the two I care most about. Let's go ahead and just allow it to generate that for us. And the real benefit of that is this get enumerator and enumerable get enumerator are kind of tricky. You have to do a lot of casting. You can see how this is being cast multiple times to be different things in order to return what we're after. But these are all just pass-throughs. Now, not all these casts are actually required. Like, honestly, we could take out this whole iCollection cast here and just say items.contains. And that's because that template automatically adds all the casting, which you do need in a couple circumstances, particularly with the get enumerator. So what are important here? The clear should understand just empties out the collection. That's all it really does. The contains is going to look and see if that item is in the collection that's being passed in. The copy to copies the items out of the collection into an array of the same type. The get enumerator needs to be there because the get enumerator is what gets you the enumerator, which means it can be used with a for each loop. Without that, you can't iterate over your collection with a for each, which is going to break a whole lot of things. You absolutely have to have those enumerators. And then we also have remove. Oh, that's the one we wrote. And so we got our two enumerators. And yeah, it just organized in alphabetical order for us a little bit. Finally, the is read only. We could also just say that is false because it will never be read only for our particular reasons. Here, items.count, we don't necessarily need to cast that. We do need to cast for the is read only if we're going to use the is read only property that's defined there, because the list by itself doesn't actually normally have one. Or you can just return false because in our case, this collection is never going to be read-only. So this gets us all of the generic collection stuff. So let's go ahead and put this inside a region. And then we will close off that region. This actually needs to end with an end region. There we go. And there's our collapse. There we go. Okay. And that just kind of cleans up a little bit where we don't have to look at all those extra methods until we need to. Because what we want to do now is implement a couple additional properties which are specific to our shopping list. So let's do a public int found item count. And this is just going to be the number of items that actually, let's do this with a full get body, because it's going to take a little bit of doing. Let's go ahead and declare an int count equals 0 for each. And this is going to be a line item in items. In order to count that, we basically just say count plus equals an actual variable name there. Item dot is found. Actually, we want to take that and make it an if statement. So if the item is found, we're going to increase the count by 1. And actually, since we're just incrementing the count, we can use the increment operator, or we could do plus equals 1. And then when we're done counting, we'll return that count. So this is a simple aggregation method. We're just counting all the items that were found. And we can do the same thing for a not found item count. Public int not found item count. And again, we'll declare a get. And we could do the shorthand here. Actually, we could do the shorthand all the way up at the top. Or we're going to go ahead and spell it out. And here, we could also do the aggregation. We could also just say return the total count. Remember, count is defined in our collection, minus the found item count, because the total number of items in our collection minus the ones that were found should be the items that are remaining to find. So this is going to do all the counts of the line items that should be on our list or not on our list. All right, so we'll go ahead and save that. And we can jump back to our shopping list control. And now we're going to modify this by adding a number of found items. And we can throw that in this dock panel really anywhere. I'm going to throw it up here at the top. And again, I'm going to use a stack panel with a horizontal alignment because I want, a orientation. I want a label, and then I want the actual value. And so on the left side, we'll have a text view whose text is just going to be, and I'll actually set it as a text property. And I'm actually going to say items to find, so we'll use the not found count. And not text view, but text block. In this case, we'll do a binding. Again, the binding binds to whatever our collection or whatever our data context is, and we'll use the path of not found items. And we don't have a quotation in there, and we close that off with a self-closing tag. So that should, as well as a stack panel, we want to actually tell it where it needs to dock. By default, it's docking to the left, and we want dock panel.dock, and we want to set that to the top. So now it's showing the items that are not found, and it will tell us exactly how many there were. Actually, let's dock that at the bottom. Okay, you can put it at the top or bottom. It really doesn't matter. But Yeah, let's put it at the top. The bottom just gets a little too crowded that way, I think. Okay. So now you might think that if we run this, it's going to give us the value. But we have an error we need to patch first. Let's see if we can find that error in the error list. App does not appear in shopping list. Okay. So this particular error, we'll run into this every now and then. You'll see something like, and look at where the actual error is. So I'll step to the side. Notice that this is an app.g.cs. That app.g file, it's not in our solution anywhere. And that's because anything with the .g before the .cs has been generated from a XAML file as a temporary step towards compilation. So when we see something like that, what we actually need to do first is clean our project. That deletes all those temporary files, and then try building again. A lot of times that will fix the issue. In this case, it did not. So it is saying shopping list failed, and if we go look at our error list, name app does not appear in shopping list. All right, so what is going on here? If we look at our namespace, it's shopping list, but our class is also shopping list. I should not have done that. So this class name needs to be unique from the namespace name, or it's going to start confusing the two. And that's exactly what has happened here. So we'll call this shopping list items. We just rename that class, and if we do a build, that hopefully will get us past that. Yep, that was exactly it. So basically, it was confusing which shopping list we're referring to. So now we fixed that. Notice that here, though, we wanted it to show us what items we should be finding. It's not showing us that. Why is that not happening? Well, if we go back to our main window, XAML.cs, we're still using an observable collection. We're not using that custom collection class we just wrote. That is exactly why. Because it doesn't have that property that gives us the number of items that are not found. But that also demonstrates something that's very important about how data binding works in C#. If that path to a property doesn't exist in the bound object, the data context object, it doesn't cause errors. It didn't crash our program. Our program ran just fine. It just didn't display any data. And that's important because we don't want that program to crash if the data is not there. We just don't want to display anything. So that is the default behavior for WPF applications. Let's go ahead and tweak this. So instead of an observable collection, we're now going to use our shopping list items. And it doesn't need to have the line item as a template because it already implies that it's a collection of shopping or of line items. And notice that we can cast that to BNI collection. It doesn't have any problem with that because we implemented that interface exactly using the line items. So other than that, this should make everything work. So we run it. Now we have our eggs. Items defined is still not being bound, or let's check on that. So let's add a breakpoint on the not found item count on the getter. And let's double check that we got our binding bound to the right thing. So if we look at our shopping list control XAML, this should be not found item count. That's probably what the problem was. So this is another thing that's extremely important to understand about data binding. Because it doesn't throw errors if it doesn't have that matching path, we need to make sure that we get the path absolutely correct. If we don't do that, then it's not actually going to bind to anything. It's not going to give us our values. So now if we run this, and notice that now we're hitting that breakpoint we added because it is checking that value. It is correctly bound. And notice it tells us now we have one item to find. Let's add another item. And add that to our list. And notice that that did not actually happen. So let's stop our program and take a look at what might be going wrong when we add that. So if we go to our shopping list control where we have this add, we are casting it to a list there. Let's go ahead and put a breakpoint at that if statement, and we'll see if we can figure out what's going on there. So we want to add a new item. We hit here, our data context, if we look at it, is a shopping list, dot shopping list items, so it is that collection. And if we step into, notice the cast was successful because we got inside here. So list is now a collection of shopping list items. So it is treated as that list. So we should be able to invoke our add on it. Let's step into that add and see if that add is actually happening here. So we get into our items.add. And that looks like it passed perfectly fine. Let's continue. Notice it's not showing up in our list. So I'm not sure what that earlier error was about, but now this is all behaving the way I expected it to. But it's not showing up in the list. And why is that? Now, if you remember when we first created our shopping list earlier in the previous exercise, we did in the main window, we used a list here. And that didn't update when we added things to it. So we switched to an observable collection and it started working. What's the difference between a list and an observable collection? It's not very big. The difference is, and we're going to implement that in our shopping list, is that the observable collection implements an extra interface. collection or notify collection changed. So this interface tells us that we need to implement an event. If we actually hover over it, notice it just says one thing. It does not implement interface member collection changed. So it wants that particular event. And that event is going to be public. It has to be public. And we're going to use the event keyword because it is an event. And then it is a notify collection changed event handler, and it expects it to have the name of, oh, let me fix this, notify, mistype that, notify collection, changed event handler. I get it spelled correctly, collection changed. And when we do that, now it's just saying we need to add, well, because this starts as null, it's saying, oh, this actually needs to be marked as something that can be null. The way you do that is you just throw that question mark in front of it. That just indicates that we know it's starting as null, that it's allowed to be null. This is how we have to define events now in C#. Version 10, they're really starting to push this idea of signaling if something potentially could be null, and we have to treat it as potentially null. But what we have here is just this collection changed event handler defining this event, which indicates that something about our collection has changed. That's really all this event means. And that's all we have to do to implement the interface, at least the letter of the law for the interface. But the intent of the interface is that when something does change, we're going to let the rest of the world, anybody who's attached to this event handler, know that that collection has changed and give you some details about that collection changed. And specifically, that collection changed happens when we add something to the list, when we wipe out everything in the list, or when we remove something from the list. So in order for this to work, after we add something to the list, we need to invoke that event handler. So that collection changed. We do question mark, period, invoke. And the invocation, this method that we're calling, takes two arguments. The first is what object this event is coming from. So who's sending this? And in our case, and generally speaking, whenever we invoke a event, we're doing it from within the class that is the source of the event. So it's just this. We just pass in this saying this is the object that you want to know it's coming from. And then the second is an event args. And if you remember from our discussion of events, different events have different kinds of event args. In this case, we're using a collection changed event arg. So a new collection changed event args. And you may be tempted to notify collection changed event args, my bad. You may be tempted to just return or leave it like this. You'll notice that it actually highlights with an error. This is one of our actually, this is actually one Microsoft error now. But it's basically telling us that we need to tell it what kind of collection changed event we're having. So this takes some additional arguments, and you can read up on those in the documentation. You can just say notify collection. And look at the actual class and notice that there are a ton of constructors here. And each one really is for a different kind of event. And though what kind of event you're looking at is this collection changed action describes what those are. And they're basically adding an item, removing an item, or adding multiple items, removing multiple items, or there's one that is a reset that says there's too many changes to actually enumerate here, so just assume that you need to start over. So when we do an add, it should be a notify collection changed action add. And I lost a parenthesis there. So at the very least, we have to say that we're adding, and then we also need to say what we are actually adding to the list. So in this case, the item. All right. With the clear, we are getting rid of everything out of the list. This is an instance where we might want to notify that it's been a reset and you just need to start over and reiterate through the list to get the current list. So for that, again, we pass this. We do a new notify collection changed event args. And our action will be the reset, just because this is a drastic enough change. We say, don't even worry, just go back and re-ask for everything, figure out what's in there. Now, some of our other methods, contains doesn't make a change to our collection. Copy to doesn't make a change. IEnumerator doesn't make a change. Remove, however, does. So after we've removed the item, we need to notify that we've removed the item. So we'd say collection changed. And a invoke with this and a new notify collection changed event args. And again, our first argument is the notify collection changed action. And we're going to say remove. We're removing an item. And then there are two constructors that potentially work with removes. Specifically, the one we want is the item that we're removing and the index that is being removed from. So item, and then also the index. Well, what is the index it's at? Well, and also notice that we're returning here, so this actually will never be triggered. So we have to rethink our logic for removing. It's not going to be as clean as it was. And one of the easier ways of doing it is we need to know the index, so let's find the index first. And you should have used index of in prior semesters. That just searches through and finds the index of the corresponding item. So we can go ahead and just say item. Now here's a question. What happens if index of doesn't find the item? Look at the return. It's the zero-based index of the first item. And if not found, it's going to be -1. So we can check to see if the item was found by just saying if index equals -1. That means we didn't find the item. We don't need to trigger the collection changed event. And we don't need to actually remove anything. We just return false. Otherwise, we're going to remove the item. And we're going to invoke this collection changed. And now we actually have our index. We can just reuse that index from above. And finally, we return true because at that point, we should have removed it from the list. Now, it's very important that we do the collection changed event invocation after the item has been removed. Because remember, an event listener gets triggered during this invoke. So if we trigger it before we remove the item, we're telling the world, hey, I've removed an item, you need to update yourself. And it goes and looks, and the item's still there, so it's going to leave it in the list. Then we remove it, our interface is going to be one step behind how we actually have the program data. So it's very important that we do the event afterwards. Now, there's also this question mark, and I told you up here when we declared the type and we threw this question mark in, that we're indicating that collection changed event handler may have a null value. The question mark usage here is a little bit different. Before this invoke, it's question mark period. What we're saying is make sure that collection changed is not null, and then call this invoke method. And if collection changed is null, then everything after that question mark doesn't happen. So this is a test to make sure it's not null before we try to call its method. And that just saves us from a null exception, which would happen if it was null. Okay, so now that we've made this change and that we've implemented the iNotify collection changed interface and we've marked that as part of this collection, now what's going to happen is when we add an item to our collection, we're going to trigger this event, which should trigger the GUI, the binding object, will receive that event and say, oh, the value has changed. I need to update my list. So let's see if we actually did this correctly, see if it works for us. So right there, we're already hitting that event handler because we added an item right at the beginning. If you remember in the main window, we add that very first item. Let's step in and see. In fact, we can even hover over this item and see that it's the eggs that we added to start with. So if we step into, we missed it. I was hoping we'd actually step into the listener that's handling that. But that's in some system code, so we don't actually have access to it anyway. But the important idea is now if we add a new item, like our milk, notice that we go through our add, and we're in here. And I'm going to take that breakpoint out, and we're going to continue. And notice that we get down and we invoke that collection changed. If we continue, now the milk shows up. So what happened there is we fired off that event, and the binding, when we create that binding, it actually attaches, in this case, to the collection changed event handler, it attaches an event listener that says, when this event happens, I'm going to take that knowledge and I'm going to use it to update the GUI. So it actually, when that happened, it updated the GUI, it added the milk, and our GUI is now updating. So that's an important piece. Whenever we're working with collections and we're data binding with those collections, we have to notify that that collection has changed using that collection changed event. Now let's run this one more time, and I'll take out all my breakpoints. Let's add that milk. So right now we have items defined as 1. If you look up in the upper corner there, we add milk. Notice items defined as still 1. Again, we're going to have to let the GUI know that that value has changed through an event. So we've implemented one interface that deals with changes. In this instance, a collection changing, so adding or removing items from a collection. There's another interface called iNotify property change, which we also need to know about. And it also defines a single event. Notify property. We need to add a namespace for this using system.object model. I think that's where that is. Maybe I'm not remembering correctly. Hurry up. no sense. Component model, not object model, component model. And now you can see if we hover over it, it tells us this needs to have an event handler, which is the property changed event. So very similar to the collection changed, we have to define an event. And the event is public event, keyword, and then the notify property changed event handler. Actually, I think it is just property changed event handler. Microsoft does not do a great job of sticking with their naming conventions. So the collection changed event handler and the property changed event handler, one of them has notify in it, one of them doesn't. Both interfaces have the notify in it though. So it's just one of those things that you have to learn as you go along. And the event name is property changed. So as the name would imply, this event needs to be triggered anytime a property of our class changes. So what properties do we have in our class? Well, we have found item count, and we have not found item count. And then we also have count. Is read-only is technically a property, but that will never change, so we don't need to worry about it. The rest of these are all methods, so we don't need to worry about them. We only have to worry about properties for the property change. So normally we would implement property change or invoke it in the setter. But if we look at found item count, not found item count, and also count, notice that there is no spot for us to put that in. There is no setter, because these are all derived properties. We're getting their value from somewhere else. And where is that somewhere else? Well, it's the collections count, technically, is where we're getting it. But the count also doesn't have a setter. It's deriving its count from how many items have been added to the collection. So we need to go to where the mutation is happening, the change to state. Where does the change to state happen? Well, it happens when we add an item, when we clear, or when we remove an item. So those are the same places we're doing the collection change. This is where our properties will also be changing. So we would need to say property change and invoke that. This, and with a property changed event, the event args are a property changed event args. And it takes one argument, which is the name of the property that's changing. And there's a couple different ways we could do this. We could do this as a string. For example, we could say count is what is changing. And that would take care of the count property. Or we can use the name of. And you've probably used type of before. Name of takes a symbol, in this case count, so the property count, and converts it to a string representation. And the benefit of doing name of here is now it's not as critical that we spell it correctly, because this count is actually the symbol, and it's going to be underlined in red if we didn't name it correctly. Just like when we type that property name anywhere in our code, versus giving it a string, it's not going to underline it if it doesn't match up with a property. So this is a slightly safer way of doing this, because it helps ensure that we spell it correctly. If you're somebody who often types a little too fast and may have transposition on numbers, or otherwise has trouble spelling things, like I sometimes do, this is a really good technique to help ensure that you don't do that. Now we have to invoke this property changed for every property in our class that will be changing when this happens. So not only is our count changing, but our not found item count will be changing, and our found item count will be changing. So we have to actually notify each one of those separately. And we really want to do this every place they change. And one of the nice things you'll notice is that all we're providing is that name. We're not providing the actual value it's changing to or anything like that. So this is pretty simple to implement. And we'll go ahead and do it in the add, in the remove, and in the clear, because those are the three that are going to change the state because they're changing the items in our collection. So if we run this again now, and fix our build error, what do we have for errors? I have a missing parenthesis, which is going to be in all three because I copy pasted. Let's fix it in all three places, build that again. So now if I add my milk, notice items defined, now we have 2. So we have hooked up both types of event notifications for when the collection changes and for when items in the collection change. Now there is one other thing we'd like to have happen. If I check these, that should update my items defined. That should no longer be showing 2. It should be showing 0 at this point because I've marked everything off my list. So why is that not working? Well, a couple different reasons. First of all, if we go to our shopping list line item, notice that we're not implementing any of those interfaces here. And this has a property is found, which we want to implement that on. So we have to go back ahead and implement that iNotify property changed here. Let the world know that that property has changed. Notice that here we did have component model already in there, so it's happy with that. So now we need to update, especially the isFound property is the one that we need for the functionality we're after, but because we're saying we're implementing this interface, technically we need to handle that in each one of these. So at this point, how do we do that? Well, in this case, we have setters, so it makes sense to invoke it in the setter. But these are auto properties. Can we do it with the auto property? No, we cannot. So at this point, we have to actually convert from auto properties to private backing fields. So in this case, string name, private backing fields, so we do underscore and name. And then we have to expand these out. So get is now going to be a method where we return a private backing field, and set is going to be property where so this is the equivalent of that auto property, but now that we have an actual setter, we can implement that property changed event, which we actually need to define still. Public event. And as you do this, there is going to be a temptation to copy paste this public event property changed event handler property changed. I will highly recommend you do not type it every time because you want to get that particular name ingrained in your head. You want to have that to be muscle memory because when exam time comes around, you got to remember what it was. You're not going to have the ability to autocomplete. So go ahead and type it out. I know it seems like a lot more work than it's worth, but in this case, it's actually very important because it's helping you remember when you come to take that exam. The other thing we might do here is go ahead and give this a default starting value of just the empty string. Okay, and then down in here, we're going to invoke that property changed. And invoke this new and we can say name of name. And we'll want to do this for the quantity, for the isFound, but not for the toString because that's a method. We don't need to worry about it in a method. So I'll let you guys finish those up. So I'm going to just jump ahead a little bit in the video to where I've done it. By the magic of video editing, I have now finished the entire line item class. If you haven't done this yourself, pause the video, finish out these properties, but now I have my documentation in place, and I have the private backing field and the property changed invocation for all three properties. The is found, the quantity, and the name. If I run this now, you might be thinking, oh, well, we did that next step. That should take care of us. If I check this box, it should change the items defined. Not yet. Because remember, items defined is bound to the shopping list property that is the found item count and the not found item count. And where are we notifying that those properties are changing? Right now, we are only notifying when we add something to the list, when we clear the list, or when we remove something from the list. That's not covering the case where the item itself is changing. So in order to do that, we need to actually know when the item is changing, and when that item changes, we need to forward that information or send another, in this case, notification that the not found and the found item counts are being updated. So what we actually need to do is we need to listen to this item that we've just added to our list. We need it to tell the list, the collection, hey, I have just updated my, I have just changed my value. So we need not only an event handlers here, but we're going to have to write a custom event listener. So let's write an event listener for the property changed event. So this is going to be, actually this can be a private event listener because it's only going to be used within this class. Handle item property changed. And like any event listener, it's going to have an object, which is the sender, where that message originated. And because what we're actually listening for is a property changed event, we're going to expect a property changed event args. And put my in the right spot. Okay. So we are writing the other side. We're writing the listener now that we're attaching to the event that's going to tell us when, or the handler, it's going to tell us when that actually happens. Oh, and we also need a return type. And with methods, or with event listeners or event handlers, it's always void. Okay. Now we know from implementing the invocation of this event that args should have a property name. And I'll ask you the question, what properties do we actually care about? What names for properties do we care about? Well, if we think back to the line item, what properties do we have in there that we might care about? We have a name. Does changing the name change those two counts we care about, the not found items and the found items? No, no effect. We don't care about name. Quantity, does changing the quantity affect it? Not the way we're defining it right now, because we're not caring how much the quantity of the line item is. We're just wondering, has that individual item, line item, been found or not? What about the is found? This one we care about. When this is found changes, that means that checkbox has been checked or unchecked, and that's changing the quantities of those two counts that we do care about. So if we jump back to our shopping list, we can put this inside an if statement and say, okay, if that property name happens to be the one I actually care about, which was the is found property, then I want to do something, and the something I want to do is I want to notify that the found item count and the not found item count are changing. Now the overall count is not changing. We haven't added an item or removed an item, but we've changed the state of one of those items. We've changed it from found to not found, or not found to found. So this is what we want to forward. This is the information we actually care about. And then anything that's not an is found, we're just going to ignore. We don't care about it, so it's fine to let go. Now, in order for this event listener to work, or event handler to work, we have to attach it. And we want to attach it specifically to the item that we're adding. So in addition to adding it to our collection, we want to add that event handler to the item. So we can say item.property changed. You can see that event is declared there, plus equals to attach an event listener. And here we would just use the event listener or event handler we've defined there, which is handle item property changed. So now, and again, it wants this to be nullable. So we'll put that in there and see if that makes it happy. And that did. So again, a change for C# version 10. So when we add an item, one of the things we're going to do, we're going to attach that event listener so that whenever that item mutates, we get notified and we can determine if we care about that mutation or not. Now, it's especially important that if you're attaching an event listener, you also detach it if you ever stop needing to listen for that event. Otherwise, we create a memory leak where we've basically created a whole bunch of event listeners that are still attached to an item, so that item never gets cleared by the garbage collector, even though we're no longer using it in any way, shape, or form. So when we remove our items, like we do in the clear, we want to remove the listener, and basically we have to do that before we clear the list. So we're actually going to do it up here at the top. For each var item in underscore items, and I'm using a var here, but you can actually use line item if you want to. We'll just say item dot, oh, actually we do need to, because no, that's a line item. So in that item, we have a property changed. Well, minus equal, which says remove handle item property changed. So that will remove that listener. And this is not underscore item, it's item. There we go. So that will remove that event listener from each one of the items in our collection. And then we invoke items.clear, so then we also empty out the list after we've done that. And then also on the remove, we need to remove that item. Basically, here we can detach the event listener either before we remove it from the list or after we remove it from the list, because we still have a reference to the actual item. So we can say item dot property changed minus equal handle property changed, handle item property changed. So basically, anytime we remove it from the list, we've got to detach the event listener. Anything we add to the list, we attach that event listener. Now that event listener is going to listen to the individual items in our list. If any of those change their values, we'll bubble that up by basically catching that event here and then creating a new property changed event args for the properties that are specific to this class. So now if we run our shopping list and we mark eggs, items to found is now 0. If we add another item, items to find is now 1. Check the milk, back to 0. Uncheck both of these, items to find is 2. So now all of this is hooked up. And all we really had to do was add a couple of event handlers to be able to notify the GUI and to set up data binding on the GUI. Now this may seem like a bit more work than you were expecting, but this actually works really well, especially as our programs start to grow larger and larger, and you're using these data classes in more places than just one. Then data binding is actually much more effective and uses a lot less coding than if you're doing it the old-fashioned way we did with Windows Forms. So hopefully that gives you a better picture of data binding and some of the power and uniqueness of what we can do with it. And we're going to continue on this theme for the next couple of modules. We're going to dig even deeper and play with it in some new ways, create some new custom controls. But this is enough to get you really started in working with that. So have a great day.